Lesson 14.6 is definite integral using FTC. What does that acronym mean? It means the fundamental theorem of calculus. And the fundamental theorem of calculus, it's a theorem, it's a rule. It's linking the concept of differentiating a function, which is what we've already spent so much time doing all of first semester plus like another quarter. It's calculating its slope rate of change at a point, and it's connecting that with now what we're doing is integrating a function, which is trying to find the area under its graph. So basically what we've got is saying we're trying to find the area of a curved function from A to B, and that's going to equal capital F of B minus capital F of A, where that is the antiderivative. So if we're to see this, we're going to have to antiderive it, which we spent doing, or we learned doing last unit, antiderive it, and then plug in the B and the A and subtract. Okay, so it's almost looking like a slope formula kind of, but it's involving antiderivatives. So number 1 says find the area under the curve of this function from 1 to 4. So what I want to do is take the antiderivative. Remember, that is doing the opposite of taking the derivative. So the derivative would say, if I have this, remember I would take the 2 times the 3 and get 6, and then I'd subtract 1 from the power. Now I'm doing the opposite, where I'm going to add 1 to the power and then divide by that new power. So if I've got negative 3x squared, I'm going to add 1 to the power, which is 2 plus 1 is 3, and divide by that 3. And then the next one, I'm going to have minus 4x, since that's to the first, I'm going to add a power and then divide by that power of 2. So that would get me a negative x to the third minus 2x squared. Then you want to write a vertical line, make it look longer than just a 1, and then we're going to write our x values from 1 to 4. This is the notation, or the way they write it once they take the antiderivative. Okay, if you were not sure, you could always ask yourself, if I take the derivative of this, does it get me back to this? Well, I'd bring the 3 in front and subtract 1 to the power, so I'd get negative 3x squared minus 4x. Boom. Okay, and then from there, you're just plugging it in. So you're going to plug in 4 first. That's where this f of b comes from. B is the higher x value minus f of a. So we're going to have a negative of 4 cubed minus 2 times 4 squared. All that minus, then plug in the 1, and I'm going to do brackets here, negative 1 cubed minus 2 times 1 squared. So we should get this to be a number and this to be a number, and then subtract them at the very end. 4 cubed is 64. That would be a negative. 4 squared is 16. 16 times negative 2 is negative 32. And so that gets negative, 96. And then this one would be 1 cubed is 1, but times negative makes it negative 1. 1 squared is 1, times negative 2 makes negative 2. That is negative 3. But then minus a negative will turn it into a positive. Negative 96 plus 3 would make a total area of negative 93. So this is the first time we've really found area under a curved function without doing anything with its graph. We're doing all the work ourselves. That means a lot of the curved area is under the x-axis. All right, let's try number 2. We're trying to find the area of this function from 0 to 3. Notice how this is just y equals negative 3. I want you to think about what that kind of line, what that line looks like. This is your x, this is your y-axis. Y equals negative 3 is going to be a horizontal line cutting through the y-axis at negative 3. So if I were to find the area under this, it's just going to be a rectangle from 0 to 3. So I'm just finding this. So you could actually draw it out, sketch it out, think of it in your head, whatever, and think, well, this is going to be 3 units this way, and actually 3 units this way, so it should be a square of 9, but it's going to be negative because it's down here. But if you don't want to draw a picture and you want to do it mathematically, you would take the antiderivative of negative 3, which happens to be a constant. Well, with a constant, you don't have any x, so you just tag on an x to it. So it's like having x to the 0, then you add 1, be x to the first. Divided by 1 is not going to change it. And then we would draw our vertical line saying we want to evaluate this from 0 to 3 for our bounds. And again, if you're not sure, think about if I were to have negative 3x and I want to take the derivative of this, think about you take 1 from the power, so that would be no x, and it would just be the constant of negative 3. Then I would have negative 3 times 3 minus negative 3 times 0. So I'm trying to get negative 3 times 3, which is negative 9, minus that's nothing. That also results in an area of negative 9. So kind of cool, I think.